Number one, factor completely. Anytime you're asked to factor, the first thing that you want to do is check to see if there's a greatest common factor. You'll want to look at the terms that you've got and see if there's something that you can take out of all of them. In some cases, you might be able to take an r out of everything, or maybe take a 2 out of everything. Here, where we've got r squared minus 81, cannot take r out of both of those, and there's no number that we'll be able to take out. But anytime you're asked to factor, you'll want to check greatest common factor, and I'll usually abbreviate that GCF, but you'll want to check that before you do anything else. Second, you'll want to notice what kind of polynomial it is. This is a binomial, which means it has two terms. Binomials, there's three ways that you can factor them. The first is difference, which is subtraction, of squares. Difference of squares, and I'll talk about squares in just a second. The second option is difference of cubes. Talk about cubes in just a second. But difference in both of those is subtraction. Here we've got a minus in the middle of the r squared and the 81, so it's definitely going to be difference of something. And the last option with binomials when you're factoring it is sum of cubes. Sum is addition, so we're definitely not going to be doing sum of anything. This is either difference of squares, difference of cubes, or it's not factorable. Squares. I'll make a list. You might write this in your notes out to the side so you can reference it while you're working through the problems in the section. But squares are anything that can be made by squaring something. So the thinking sort of is 1 squared, 2 squared, 3 squared. That's what we're thinking when we make this list, and that goes on. But 1 squared equals 1. 2 squared is 4. 3 squared is 9. 4 squared would be 16, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. And you might even want to make a longer list than that. Cubes is the same idea, except we're cubing things. 1 cubed, 2 cubed, 3 cubed. And 1 cubed, 1 times 1 times 1, 2 times 2 times 2. Be careful you don't put 6 there. 2 times 2 is 4, times another 2 is 8. 3 cubed is 27, 4 cubed is 64, 5 cubed, 125, 216, 343, 512, on down. You don't need to make as long a list of cubes because you're not going to see as many of those as you are of the different types of squares that you might see. But back to the r squared minus 81. So definitely talking about difference. So we're either talking about difference of squares, difference of cubes, and if it's neither of those, we'll just say it's not factorable. But if we look at our squares list, and by the way, let me add on to this just a little bit. You also have variable squares, and I'll just go ahead and simplify this as x squared would be the first one, x to the 4th, x to the 6th, and so on. Basically, if it's a multiple of 2, x to the 2nd, x to the 4th, x to the 6th, then it's a square. Cubes start with x to the 3rd, and they go up by 3. Typically, though, you'll just see the x squared, the x to the 3rd when you're talking about squares or cubes. And in this case, we've got r squared, which makes it a square. 81, also on the list here, is a square. So this is the difference of squares. And difference of squares, the formula for that, erase some of this. So I'll erase these two for now. Difference of squares, the formula for that is a minus b, a plus b. And you'll get pretty familiar with this, but a is just the square root of the first term. The first term being the r squared, so the square root of that is just r. B then is the square root of the second term. The square root of 81 is 9, just like the square root of 25 is 5. The square root of 36 is 6. So b in this case is 9. So basically all you're going to do, once you've got a and b, you're just going to set a minus b and then a plus b. So back up here to the r squared minus 81. A minus b, a plus b. And that's all there is to it. Again, just to recap, factoring, first thing you'll want to do is check greatest common factor. Second thing you'll want to do is look at what kind of polynomial it is. We'll look at binomials. We'll look at trinomials, which have 3 terms. We'll also look at expressions that have 4 terms. But we'll deal with all of them a little bit differently after that first step. For binomials, you'll check those 3. Is it difference of squares? Is it difference of cubes? Is it sum of cubes? Hopefully the difference part and the sum parts are pretty easy to recognize. Then hopefully you've got a reference sheet maybe next to you in your notes where you can spot a square really quickly and you can spot a cube really quickly. Number 2, factor completely 2s squared plus 9s plus 9. Again, anytime you see that word factor, start with greatest common factor, see if there is one. Most of the time there won't be, but you'll want to take a second to see if there is something. So maybe you can take 2 out of everything. In this case, we can't. Maybe you can take s out of everything. Almost, but this last term doesn't have an s on it, so we can't take s out of everything. So just like the last one, not going to be able to take a greatest common factor out. Second, you want to look at what kind of polynomial it is. Is it a binomial? Is it a trinomial? In this case, we've got 3 terms, so it's a trinomial. And trinomials factor into 2 parentheses. And the first thing in both those parentheses, maybe you guys know this already, it's got to multiply to be the first thing in the expression. So I'm going to go ahead and put the 2 parentheses, and let me erase this just a little bit. So again, the first thing in both of those has to multiply to be 2s squared. The s squared part, pretty easy. You need to have an s and an s in order to make s squared. And you also need 2 numbers in front of those s's that would multiply to be 2. Not a lot of options. The only things that multiply to be 2 are 2 and 1. Another thing, if you've got plus and plus here, you can just go ahead and assume you're going to have plus and plus in the middle. And then lastly, the 2 things that go on the end there have to multiply to be this final term, the 9. So 2 things that multiply to be 9. We want them to add to be 9, and then we'll check here in a second to see if this all works out. But with 9, there's a few different options. It could be 1 and 9. Maybe it's 3 and 3. Typically, you'll want to start with the closest, just because percentage-wise, the ones that are further apart, like the 1 and the 9, you'll see those less frequently. But we'll go ahead and plug in 3 and 3, and we'll see if this works out okay. What we're hoping is that the products of the inner and the outer terms add to be the 9s in the middle. So what we'll do is we'll multiply on the inside. Do this in white. Going to multiply those. So 3 and 1, I'll just write down the numbers there because that's the important bit. 3 times 1 is 3, and then on the outside, 2 times 3 is 6. And again, we're wanting this to add to be this middle term up here, 9s. And with 3 and 6, they do add to be 9, so that works out. And so your final answer is just these 2 parentheses. And by the way, you might know this already, but when you're entering in 1s, you'll leave off the 1. We just put s anytime it's 1s, so leave off this 1 here. So 2s plus 3 times s plus 3 is the final answer. Number 3, factor completely. Again, factor. When you see that word, you want to check greatest common factor. So we're looking to see if there's something we can take out. out of all these three terms, we can't take c out of everything because the middle term doesn't have a c. And there's no number that we can take out of all of these, so no greatest common factor again. Second, it's not a binomial because it has three terms. This is a trinomial. Trinomials are going to factor into two parentheses. But one thing that we will want to do before we go into the factoring is, you'll notice that these aren't in what we call descending order. And basically that just means that you'll get familiar with the way these things look, but you go from c squared to a c term, and then the number that doesn't have a variable on it goes last. So the way we'd want to rewrite this is c squared first, the 14c in the middle, and then the 49 on the end, and then we'll factor it from there. So again, the first two things have to multiply to be this first thing in the trinomial. So c squared we can make with c and c. We also have plus and plus there, which makes the sign in the middle pretty easy. And then the last two things in both those parentheses have to multiply to be 49. 49 has a couple different options, 1 and 49, 7 and 7. And again, go with the closer pair just because percentage-wise that's what you see most often. So we'll put those 7s in, and then we'll check. Underneath we've got 7 when we multiply those. Underneath we've got 7, and that does give us 14. And by the way, we're taking 7 times 1 in both of those cases, since 1 is the number out front. So 7 times 1 is 7. 7 times 1 is 7. And we do get this 14c in the middle here that we wanted. And again, if you're entering that in the computer, leave off the 1 in front of the c. Number 4, 36r squared minus 25p squared. We got that word factor again. So number 1, GCF, any common factor we can take out. 36 and 25 don't have anything in common. Not a lot of things that go into 25, just 5 and 25 basically. Neither of those go into 36. And then we don't have any r that we can take out of both terms. We don't have a p that we can take out of both terms. So again, no greatest common factor. Second, looking at what kind of polynomial this is. We've only got two terms, so this is not a trinomial. Two terms are just binomials, so we're back to those. Keep in mind, binomials is only three ways. Difference of squares, hopefully you've got that list available to you. Difference of cubes, and then sum of cubes. Again, sum and difference. Difference is subtraction, sum is addition. So this is definitely not sum of cubes. If we're looking at our squares list, you'll notice that 36 and 25 are both on there. R squared and p squared would both be on there because they're equivalent to the x squared part. But difference of squares is what we want to go with. So we're doing a minus b, a plus b is our formula. A in this case, again, is the square root of the first term. So if we're looking at this 36r squared, the square root of 36 is 6. The square root of r squared, the thing that multiplies to make r squared, is r. The 25, call this b. B, the square root of the second term. So square root of 25p squared. Square root of 25, hopefully you know, is 5, and the square root of p squared is p. So as long as you can figure out what a is, as long as you can figure out what b is, it should be pretty easy. You're just taking a, 6r, and subtracting b. A plus b. Number 5, factor completely. First, check to see if there's something you can take out. Can't take s out of both of those, so that's basically all you need to look at as far as greatest common factor goes. Not going to be a greatest common factor on this one. It is a binomial. So GCF, we check that, nothing there. Binomial. got a minus in the middle there, so this would only be difference of squares or difference of cubes. And the s to the sixth, so keep in mind that's equivalent to x. So s to the sixth, you'll notice, is a square and it's also a cube. So you've got to make a judgment on whether or not this is difference of squares or difference of cubes, depending on the 729. If you have a list of squares and cubes, it's likely that your list doesn't go all the way to 729. So probably the fastest way to do this is to use a calculator on the 729. Check to see if it's got a square root, and then if not, check to see if it's got a cube root. So on the calculator, square root of 729, that comes out to 27. So that comes out nicely. Cube root of 729 comes out to 9. So this, you could write this as the difference of cubes or the difference of squares. What you'll want to do, though, is if you've got both those options, this is a square and a cube, 729 is a square and a cube. And by the way, we know 729 is a square because it comes out to a nice whole number like that when you put it in the calculator. We know it's a cube because it comes out to a nice whole number like 9. So this is the difference of squares, and it's also the difference of cubes. But in that case, you'll want to start with the difference of squares. So we're going to want to know the square root of the first one, the square root of the second one, because we're going to do a minus b, a plus b. So a is going to be the square root of s to the sixth. So you basically just want to half that exponent. So s to the third. And then b, the square root of 729, which we found out over here was 27. Okay, so we're going to do a minus b, a plus b. And then a plus b. And normally this is where you'd stop, but this one's a little bit more complex than that, because you might notice that with this first parentheses, we've got a binomial that happens to be the difference of cubes. S to the third is a cube. 27, if you've got your list of numbers for cubes, 1, 8, 27 is the third cube that comes up. So we've got difference of cubes, and we've also got sum of cubes. So we could factor it further. Sum of cubes we can factor further also. Okay, so I'm going to erase a lot of this, and we'll talk about difference of cubes and sum of cubes and how we work out those. So with difference of cubes, the formula for difference and sum is basically the same. For difference of cubes, it's a minus b, and then we go a squared plus ab plus b squared. And you might write these on a separate sheet of paper just so you have them to reference. And be careful when you're doing difference and sum, because the formulas are almost exactly the same, but sum of cubes starts with a plus, and then it goes a squared minus ab plus b squared. So then we're back to determining what, draw a line here, determining what a is and what b is. A is going to be, since we're talking about cubes here, is going to be the cube root of the first term, and then b is going to be the cube root of the second. So cube root of the first, the thing that you would multiply 3 times to make it, the cube root of s to the third is just s. And then b, the cube root of the 27. So we're saying what multiplies by itself 3 times to make 27, and that ends up being 3. You'll get familiar with these. The cube root of 8 is 2, cube root of 64 is 4, Cube root of 27 is 3. So basically, once you determine what A is and what B is, you can plug those into this formula, A plus B. And then you're going to square whatever A is. So we're going to square the S. That's just going to be S squared. And then you're subtracting A, B. And they're butted up against each other, so we're multiplying. So you're taking S times 3, which will just be 3S. And then last, we're going to square whatever B is. So B is 3, so we're going to square that. So we're going to deal with this first one as if it's difference of squares, or difference of cubes, rather, because it is. So A minus B. And then the second part of it, so over here, and then the second part, A squared. So A squared, which is S squared, plus AB. We're going to multiply down here. We're going to multiply S and 3. And then we're going to add B squared. So B is 3, so if we square that, we get 9. Okay, and I'll do the second part here. This is the sum of cubes. So we're starting with A plus B, just tacking that on. So A plus B, A plus B. And then we want to square A. And then subtract A times B. So S times 3, which we're just going to write as 3S. And then plus B squared. So we're just going to add B is 3. So if we square that, we get 9 again. All right. So pretty lengthy, but that's the conclusion of this problem. Maybe one of the more complicated ones that you'll see in the section. Number 6, factor the following expression completely. MH plus HS minus MY minus YS. So again, first thing you want to do is check GCF. So something we can take out of everything. Can't take M out of everything because we don't have an M in the second term. Can't take H out of everything because we don't have an H in the third term. So nothing we can take out of everything. Second, you want to look at what kind of polynomial it is. If it's a binomial, we're checking those 3 things: difference of squares, difference of cubes, and sum of cubes. Definitely not a binomial. Binomial only has 2 terms. Trinomials, you're factoring into 2 parentheses, and then you're just filling things in. This one, though, has 4 terms. These ones we're going to factor by grouping. Factor by grouping. And what that means is you're going to want to group off 2 of these and then group off another 2 of them. And you'll start by looking at the first 2. If we were to group those, we could factor them by taking out an H. Both of those terms have an H, so we could do that. If we look at the third and the fourth terms, nothing we can take out of both of those. We can't take an M out of both terms. We can't take a Y out of both terms. Or actually, we can take a Y out of both terms. So if you can take something out of both terms, then go ahead and do that. So we'll go through this process. Here we can take out an H out of the first term, and then put a parentheses, and then write what's left when you take that out. With this first term, when we take an H out, we're left with an M. With the second term, when we take H out, we're left with an S. And then the second pairing, make sure you notice that you've got a minus there. We're going to take out a Y out of both of those, but we're going to want to take out a minus Y. And then write what's left. So if you take negative Y out of that, my, you're left with M. And then be careful here, because if you take out a negative, that's going to change the second sign. It's going to be plus. And then if you took out the negative Y, then you're just left with the S. And what you'll want to notice at that point, hopefully what you've got here is an M plus S. You've got an M plus S, which is what we call a common binomial. So the M plus S part, since it's common to both, we can take that out. And then all we're going to do is multiply it by whatever was left. On this first one, when we took out m plus s, we're left with h. On the second one, when we took out m plus s, we're left with negative y. So basically just the first part on both of those. Number 7, factor completely. Negative 3x squared plus 4x cubed plus 8x minus 6. Can almost take x out of everything, but there's no x on that last term, so we can't take x out. Next, look at what kind of polynomial it is, if it's binomial, if it's trinomial, if it has 4 terms. This one has 4 terms, so we're going to group. So grouping the first 2, grouping the third and the fourth. And we're going to try to factor something out. If you look at the first 2 terms, number-wise, we can't take anything out of negative 3 and 4. They don't have anything in common. But both of those terms have an x. And in this case, we can take out 2 x's. We can take out 2 out of the first term. We can take 2 out of the second one. And then write what's left after that. If you take x squared out of the first term, you're left with negative 3. If you take x squared out of the second term, you're still left with positive 4. And since we only took out 2 x's, there's 1 left. With the third and the fourth terms, we're grouping those, and hopefully you notice there is something that we can take out. 2, positive 2. And then write what's left when you take that 2 out. When you take 2 out of 8x, you're left with 4 and the x. If you take 2 out of negative 6, you're left with negative 3. And just like the last one, the hope is that the parentheses part, the binomial part, is the same. And these might look different, but there's a positive 4x there, a positive 4x there. There's a negative 3 and a negative 3. These are actually the same thing, just like in the same way that 3 plus 4 is the same as 4 plus 3. They're the same things. So since they're identical, we can take them out. I'm going to write this as 4x minus 3, taking that out, and we're going to multiply it by whatever was left when we take that common term out. So 4x minus 3 taken out, and we're left with x squared plus